Welcome back. We're going to look at some Pythagoras now. So this is just a review. We've done Pythagoras before, you should know this, but just in case you've forgotten, we're going to practice a couple of different ways of using Pythagoras. Now, hopefully we remember the basics, but I will draw you a triangle. Now, Pythagoras only works on right-angled triangles, remember. It does not work on any other kind of triangle. All right, so if we have our little right angle here, it doesn't matter which side is A and B, could be either, as long as this is C. Now C is always the hypotenuse, hopefully we remember that. And the hypotenuse is always the longest side and it's always opposite the right angle, okay? So it's opposite the right angle and it's always the longest side. And our rule is A squared plus B squared equals C squared. So this is our rule that we're going to use all the time. Again, it doesn't matter which one A and B is, but it definitely matters which one C is. So let's do a really common Pythagorean triad, which is what perfect numbers are known as. So let's say that I call this 3, this one 4, and this one is my unknown. So I'm going to use this formula to find my unknown. So again, these are going to be A and B, and it doesn't matter which one is which, but it definitely matters that this one is C. So I'm going to say 3 squared plus 4 squared equals x squared. Now, sometimes people try and add these and say that this is 7 squared. That's not right. You must square each number individually. So 3 squared is 9. Remember, squared means times by itself. 4 squared is 16. We don't know what that is. 9 plus 16 is 25. And remember, the opposite of squaring is taking the square root. So if I said 10 squared equals 100, then the square root of 100 equals 10, right? It's just the opposite of squaring. So that means the square root of 25 is x, and what times itself equals 25? Well, it's 5. So that works. So x is 5. Now we can do this where the unknown value is either A or B, which is, there's one extra step, but it's still relatively easy. Okay, let's say that I said this was 5, this was 4, and this time that was my unknown. I'm still going to use my formula, but this time A is my unknown. It could be B, it really doesn't matter. So x squared plus 4 squared equals 5 squared. It's really important that this is still by itself on the other side of the equal sign. So x squared plus 16 equals 25. 4 squared is 16, 5 squared is 25. Now I'm going to use my linear algebra skills to rearrange this equation to get x by itself. So x squared equals 25 minus 16. So x squared equals 9. So x equals the square root of 9. So x is 3. Now this is obviously true because I used the same numbers from the last example. I just wanted to show you how it worked. So remember, if I went through that too quickly for you, if this is adding, you put it on the other side and do the opposite. So if I'm adding 16 here, I'm subtracting 16 here. I put those together to get 9. The opposite of squaring is taking the square root, and 3 times 3 is 9. So the square root of 9 is 3. All right, so hopefully we remember how to do Pythagoras. Now it can get a little trickier with decimals, but you're allowed to use a calculator for that. And I'm going to have to grab my calculator. So we can definitely do these where the answer is sometimes a horrible decimal, but that is totally fine. So let's say that I have a triangle that looks like this. I'm going to call this one 2, and this one can be 7, and this can be x. So I'm going to follow the same rule. I'm going to say that 2 squared plus 7 squared equals x squared. 2 squared is 4, 7 squared is 49. X squared, put these together, you get 53. Now, I'm going to say the square root of 53, whoops, why did I write 52, is x. Now, I know this is going to be 7 point something, right? Because the square root of 49 is 7, and this is a little bit more than that. So it's going to be 7 point something, but I'm just going to type it into a calculator. So the square root of 53 is 7.28. So if you need to round in these cases, which you will a lot in this topic, please give me 2 decimal places all the time. Round to 2 decimal places. Okay, let's do one more where the unknown is on the shorter side. So let's draw it backwards for argument's sake. Oh, why have I got lined paper instead of gridded? That's weird. Okay. Okay, so this one can be 12, this one can be x, and this one can be 6. I know that's not to scale, but who cares? Okay, so I'm going to do the same thing. I'm going to say that x squared plus 6 squared equals 12 squared, because this is my hypotenuse. It goes by itself. So x squared plus 36 equals 144, which means x squared equals 144 minus 36, which means x squared equals, we do that as a subtraction, and we end up with 8. So x is the square root of 8, which I know is going to be a little bit under 3 because the square root of 9 is 3, so it's got to be a little bit less than 3. And I end up with 2.83, which is pretty much what I thought, which is great. So use your common sense to check your answers. If I got something that was not just under 3, I would know that I made a mistake somewhere. I must have pressed a weird button on my calculator. Yeah, just check your answers. So hopefully that is enough of a Pythagoras review, and we're going to start looking at some more trigonometry next.